Hello everyone. So welcome to today's Leetcode daily question, that is single threaded CPU. So you have been given a number of tasks and each task will have its own enqueue time, that is a time at which it enters the list, and second a processing time, that is the time it requires to be processed. So there will be a 2D integer array given to us called task, and task of I is equal to enqueue time followed by process time. So now what you have to return is that you have to return the order in which the CPU will process the task. Now since it is a single threaded CPU, so at a time it can just perform only one task and nothing else. It is not a multitasking CPU. So there can be four possibilities. If the CPU is idle, so and there are no available tasks, so of course it will remain idle. And if the CPU is idle and there are tasks available, so it will choose the task with the shortest processing time. So the process with the shortest processing time available at that time will be chosen. So again, if there are multiple tasks available with the same processing time, so then it will choose the task with the lowest index, that is the smallest index it will choose if both the tasks have the same processing time. Now once a task is started, since it is a single threaded CPU, so the process will and the CPU will process the entire task without stopping. And of course the CPU can finish a task and then start a new one instantly. So main thing is that first of all we have to take care of the enqueue time, that is the task which is available at a particular second. And second thing is that we have to order them such that we pick out the list. It's pick out a task with the least processing time at that out of all the tasks which are available at that time. And again, one small condition is that if the processing time is equal, then the task with the smallest index should be chosen. So this can be done by using two priority queue, and it is not a simple priority queue, but you have to use a comparator. So what is comparator? So by default priority queue, what it does is that it sorts the array or sorts the elements you enter by smallest to from lowest to highest. But since it is a 2D array first of all, and secondly we have to do it according to our convenience, like that is I have declared one priority queue task list which will sort the elements based on the enqueue time, that is the time at which it enters the list. And second priority queue I have chosen is available list. Now this it will sort the elements based on the processing time. Now if the processing time is equal, that is like here I have written, if suppose there are two tasks A and B and processing time of both the tasks are not equal, so of course the task with the smallest processing time will be chosen. Else if the processing time is equal, that is the second condition after the question mark, we have the first condition, that is if this is true. And if the that is if this condition, that is both the processing time is not equal, so this will happen, that is the smallest smallest processing time task will be chosen. Now if this condition is false, that is both the processing time is equal, so now it will return the task with the smallest index, as you can see here. So I have declared a comparator for this, and its function is to sort the elements according to our convenience. Now since there are three variables, as you can see, enqueue, process time, and index. So for this, what I have done is that I have declared a class called task. It takes the input as index, enqueue time, processing time. Since at the end we have to return the index, as you can see, order in which the CPU will process. So you have to return the order of the index. That is the index you have to return. So like here if you see, so here the task number 0 for will take place first, then second, then third, then first. So okay, so now next what I have done is that I have first of all, this will be our main priority queue. Now for I equal to 0 to whatever task are there, I will just simply create a new object of it using task, and then I will add that to task list. Now new task is basically this class which I have declared. Okay, so I will first send all the objects in the this first priority queue. Now next what I will do next is the main part. So I have declared a current time. So now what will be the current time? Current time will be the first element's enqueue time, that is the first element of the task list, and its enqueue time will be the current time initially, and index will be 0. Index is basically for storing the value in the answer at the end. So now here something happens which I will explain you in the whiteboard. So now let me copy paste this and we will meet on the whiteboard. So I copy pasted the code, and we have our two priority queue, that is task, and the second one which is available list. Okay, so this is available list, second one, and the order, and this is the question. So just make a note that first will be NQ time, and then will be the process time as it is given in the question. Okay, so this is the format. So okay, now first of all I will declare, so I've declared it. Now answer will be also declared over here, so this will be our answer array which will at the end store the actual answer. And okay, now what I will do is that now here I will create a new object for all the tasks, and I will simply add that to a task list, that is this priority queue. So okay, so now since I am adding it to priority queue, it will automatically be sorted according to the NQ time, since in the task list is according to the NQ time. So I will just add it. Now as you can see, it is already sorted in the format of NQ time, because 1 2 3 and 4 is the NQ time. So if it is sorted, so it will become 1 comma 2 2 comma 4 3 comma 2 and 4 comma 1. Now of course these are objects, so of course there will be index for it, but since to save space just for explaining, I am just I will be writing only 1 comma 2, and object we will take a reference from here. But in actual there will be we will get to know the index by using the class object. So I've added all the tasks to the priority queue task list, and of course it is now sorted as the priority queue will sort it. So this part is done, this part is done. So now next part. So now here what I will do is I will initialize a current time variable, and I will initialize it to task list dot peak, that is the first element of task, to its NQ time. That is the I will initialize current time to the first element's NQ time. Now here the first element was 1 comma 2, that is object 1 2 and index 0. So its NQ time is 1. So current time, that is CT, will be now 1. Okay, and similarly what I will do is that I will also initialize a variable called index, and I will idx equal to 0. So I will initialize that to 0. So idx will now become 0 for now. So I've done that. So now we will enter a while loop. Now what is the condition for while loop? While a task list dot size not equal to 0, or available list dot size not equal to 0. So if that is till we will and will be in the while loop till any one of this list does not become 0. That is size does not become 0. So now the next while loop inside it. Now while task list dot size not equal to 0 and task list dot peak, that is the first element of task list, its NQ time is less than equal to current time. That is while we do not encounter an element whose NQ time is greater than the current time, we will do the following thing. Now what is the following thing? We will add that task list, that is we will add that element whose NQ time is less than equal to 0 to available list. So okay, we will now current time is 1, and its now its NQ time, that is its NQ time is 1. So since it is less than equal to 1, so we will simply add this element to available. Now this becomes here. Okay, as you can see, we have removed it from task list, and we have added to available list. Now since the second element, now this will be at the top, so its NQ time is 2, that is greater than 1, so we will stop over here. Now what we will do? Now the next thing, if available list dot size not equal to 0, yes, the size is not equal to 0. So what we will do, we will place the answer, that is at the index idx, we will store available list dot peak dot index, that is we will store its index. Now if you see over here, its original index was 0, so 0 will be stored at idx. Okay, at 0th index, and sorry, so what will be stored here, its index will be stored. So at index 0 we will store 0, since its index was also 0 over here. So this will be taken from the class object we declared, and then idx will be increased by 1, so it became 1 now. Now the next we will move, we won't go into else part. So now the next thing, now again we are okay, so now again we are at the condition, so it is not true since both the lists are not size is not 0. So again we will enter this small while loop, and here we will now, okay, so now we forgot one thing. In the previous thing we have to increment current time, that is current time is equal to current time plus whatever we removed it. So we have to remove also from this available list. So available list dot remove dot process time. So now what we'll do is we will remove this 1 comma 2, and we will add its process time to current time. So now current time, its process time was 2, so it became 1 plus 2, that is 3, and we will remove this element 1 comma 2. So let me remove it. Okay, so I have removed it. Now we will move to the first part. So now available list dot size is equal to 0, but task list dot size is not equal to 0. So we will again enter the loop. So now the first part again current. So we will till task list dot peak dot enqueue time is less than equal to current time. So now its enqueue time is 2. So it is less than or equal to 3. Okay. So we will move this element to available list, and also the next element, it is 3 comma 2, its enqueue time is 3, that is less than equal to current time. So we will also move this element to the available list. Okay, so this is moved over here. Okay, great. So the next part is, now since available list is not equal to 0, that is size, so again we will store in answer available list dot peak, that is the first element of the available list, its index to the answer. But again, now as I said, available list also has its own sorting method. So as you can see, it will first compare the process time of both index, now both tasks. Now the process time of both are not equal. So if they are not equal, so simply the smallest processing time will be at the prior position. So as you can see here 3 comma 2 has a processing time lesser than 2 comma 4, that is 2 is less than 4. So here the first element would be 3 comma 2 instead of 2 comma 4. Okay, so we have to also, so it will also be sorted automatically, so we have to keep that in mind. So now the first element will be 3 comma 2. Now its index will be added to the answer, that is at the index 1. So its index was 3 comma 2 has 2, so its index will be added, and it will be increased by 1, so it will become 2 now. And of course we will remove this 3 comma 2, and by removing we'll add that its processing time to the current time. So its processing time was 2, so it now current time has become 5, and we will remove this 3 comma 2 from here. So this 3 comma 2 will be removed. Okay, so now moving to the next part, again we will now we have 2 comma 4 in the available list, and we have 4 comma 1 in the task list. Now again we will move to this loop. Now since its enqueue time is less than equal to 5, we will have to again just move this element to the available list. Again the sorting will happen in the available list. Now it's both the processing time is not equal, so this will be first because it has one process time and it has 4. So it will be as this, and again we will have this as the first element. So as you can see, we have saved time by not again transferring 2 comma 4 to task and again moving it over to avail, because this saves time, because we do not otherwise what we could have done is that we could have again after this loop we could have again transferred all the elements of avail to task, but it would have taken more time. Now since 2 comma 4 is already available in the avail list, so it saves our time. So now we will add this, so simply we will add its index to the answer, that is at second index. So its index was 3, so okay, we got a 3 over here, and the we will remove it, and while removing it, we will add its process time to current time. Now current time became 6, so we will simply remove this now 4 comma 1. Now 4 comma 1 will be removed. Okay, so now we have only a 2 comma 4 in available. Now since our available list dot size is not equal to 0, we will enter it again. Now while we do not have any element in task. So this loop is not feasible now, since task list dot size is equal to 0. Now if available list dot size is not equal to 0, so simply what we will do, we will do the same thing, that is we will add its index to answer. So its index was 1, so 1 will be added over here, and again we will add the current time, that is current time is equal to current time plus the its process time, so it became 10 now. 6 plus 4. So now we again move to the first. So again now both the elements, that is after removing this, we have to remove this also. So after removing this, both the lists are 0 now, size is 0, so we will exit this list and we will return the answer. So 0231 was the answer, and as you can see 0231 is submitted. Now in the second example, simple one change is there, that all the enqueue time was same. So now when we transfer it to available, there the sorting will take place and according to the process time. Okay, so I hope you understood the I hope you understood the solution. So we had to use some comparator operator, and it was a simple one. So now let's just submit it and check. So as you can see, it is getting submitted, and this was the solution which I explained to you. And thank you for being with me. I hope you like the solution. So do like and subscribe our channel, and also do let me know your feedbacks and how I can improve in making the video. So thank you very much, and have a nice day.